My name is Michael Webb. I am the president of SimSystem USA. I run the US operations for SimSystem. We are a global company. However, we do develop the MillBox CAM software among many other solutions. We are an open CAM solution, and of course, here today to show you guys a couple of new pieces of information that I think could be very helpful to either users that are considering purchasing MillBox, or in particular users that maybe already have MillBox, or some of our previous released products like Sum3D. That's our legacy CAM software that we've had that was replaced by MillBox. And what I'm going to be showing you guys today are some of those core new features that you can expect to see in those later versions. So without further ado, let's go ahead and jump into it. And what I'm going to do is show you guys well, I'm going to go over some of the items that we're going to be covering today. So one of the topics are going to be abutment screw hole obstructions, basically analyzing MillBox's capability to analyze and find, not only find those problems, but repair those problems, which is kind of unprecedented when you're talking about CAM software. No other CAM software does this to date, especially on the dental side. And designated milling zones, paintbrushing tool. Essentially, this is a tool that allows us to customize how we want the mill to run, and allows us to manually go in and designate surfaces that the machine can go in and do manual tuning or refinement on. So really nice feature there. As well as the new restoration types that have been released here recently within MillBox. One of the importances behind staying up to date, making sure that you have the latest annual maintenance, is access not only to bug fixes and access to new features and things like that, but also having access to new restoration types that we release. So the CAM software, or your CAD software, as they release new restoration types, the CAM software essentially has to follow suit. So there's a little bit of development that goes on our end. We usually get a bunch of samples, a couple hundred cases that we'll go through and program the CAM on how to automatically recognize those. And that's very important when you're trying to CAM out new restoration types. You want to make sure that the selection within the CAM exists, because if you're using the wrong restoration types, well, then you could potentially have the wrong behavior or incorrect behavior inside of the mill. So now that we've covered those three topics or agenda items that we're going to discuss today, I'm going to go ahead and transition over to MillBox here, and we're going to actually show you guys some files and how that correction actually works. So I've got a file preloaded here. I'm actually going to come back to that later. I just wanted to kind of pre-calculate that so that way we had a file to look at later. And I'm just going to select a machine and a fixture for us to import some parts into, and then we'll go ahead and bring those parts in. So I know I have a screw retained bridge that has some issues, so I'm going to go ahead and pull that in. And this covers two items, actually, some of our new restoration types you can see here, but we'll cover those as we're actually importing the parts. Post and cores here, as well as anatomic, hybrid, and hybrid bridge. So this is one of those that we're going to talk about shortly. And then I'm also going to pull in a screw retained crown. So this is the anatomic hybrid. Previously, you guys may have only seen hybrid abutment as a choice here, and we want to highlight the differences between hybrid abutment and anatomic hybrid. So I'm going to import the same restoration, the screw retained crown. This is the file right here. I'm going to import it twice. I'm going to pull it in as the new restoration type, which is anatomic hybrid. And then I'm also going to import it as a standard hybrid abutment, which is basically for anybody that has MillBox 2020 and earlier, you're only going to see the hybrid abutment option. And I'll show you the reason why we created a new restoration type for it. So that was just kind of prompting me that I've already imported the restoration. It's just making sure, like, hey, are you sure you want to import this file again? To which I answered yes. So we'll give that some time to finish importing. As we can see, the bridge, it's a more complex case. So of course, it takes a little bit more time for the CAM to detect and process that. But we can go ahead and start looking at our files here just to kind of see what the differences are. So over here on my left, this is going to be that new restoration type, which is the anatomic hybrid abutment. So if I click on the restoration itself, okay, got a little bit of a froze up here for me. I think it's actually pulling that file in now, so we'll give it just a second here to respond. But over here on the left, the main differences that you'll notice is, well, the only difference that you'll notice is this one has a pink arrow pointing down from the top. And for those of you that have been using the latest version of MillBox, you're probably already familiar with what this arrow does. But for those of you that aren't, or if this arrow right here is new to you, what you want to consider is this is a secondary finishing axis. So what does that mean? That means that the finishing toolpath for the zero side, or the top of this restoration, is actually going to be adjusted to conform with the insertion direction that has been detected by the CAM software. Now, why is that important? Because it's instead of having the tool come in from the top or the anatomical side, just purely from the top without any angulation, it's now going to tilt that tool to a slightly different direction to come in according to this pink arrow. So the results of this on a screw retain crown could potentially be a problem. And the reason I say that it could potentially be a problem is because we don't really have a top cap on this restoration. All we have is anatomy. So if we offset our finishing tool path, we're going to have a problem. So the reason that this popped up is because the bridge finally caught up and imported, and it said there are one or more obstructed bores. Do you want to automatically fix those? So we'll kind of go over that here in just a second, but I'm going to say no, I don't want to fix those. So right now we're talking about the new restoration types. Let me go over this real quick and show you. This is selected as a hybrid abutment. You can see that's what I imported it as, and this one was imported as an anatomic hybrid. So that's the only or the main differences between the two, is this little pink axis or arrow that gets detected there. Now, let me, just to illustrate a little bit better for you guys, I want to pull in an actual hybrid abutment that has a top cap, just to show situationally when you actually need to use hybrid abutment. And so let's see, I think that this one has like an angled top cap maybe. Okay, this one probably is a slightly angled top cap. So I'm going to go ahead and import this file. And when I say the top cap, I'm talking about the portion above the shoulder of that abutment. So hybrid abutments will always have a shoulder, and that's how you'll be able to recognize those parts. And you can see here, in fact, it detected a secondary axis, but in this particular case, there may still actually be some undercut area because of that. So I can actually change that secondary insertion direction. But you can see when I click on that axis, it actually orientates the CAM software to how it would come in and finish this part, which in this particular case, because it's not going according to a top cap, that could potentially result in some, particularly on the areas where, like right here, where you see this equator line, this white line that goes around the restoration, that area could have some undercut areas because of that shifted tool path, and we could have some material that's unfinished down here. So that's why we separated out the restoration types, because our anatomic hybrids, or when we have anatomy, we just want the tool path to come in straight from the top and mill it out. So that way any undercuts that are present can still be touched by the regular undercut operation, but our finishing operation is going to finish out the restoration properly. So let's get rid of this file here, and we'll talk a little bit more about the other restoration type that we have here, which is the hybrid bridge. So this is the hybrid bridge. Essentially, we've spliced this out because certain restorations, of course, like a hybrid bridge, would have multiple little channels here. Now, the best way to understand the difference between, let's say, the hybrid bridge, which is this one right here, and let's say we're comparing that to the abutment bridge or the anatomic abutment bridge. Well, it's the same concept. So when we talk about abutment bridge and anatomic abutment bridge, the only differences between those is one has anatomy and the other one doesn't. Now, when we're talking about the difference between a standard hybrid and then an abutment, we're talking about one has a tie base and one doesn't. So usually the best rule of thumb that I use is if it has a screw rest seat, then that would be considered an abutment. So if we're looking at this file right here, we can look inside and we can actually see inside there's a internal rest seat for that screw. So that would be an example of a standard abutment. And as you can see on these hybrid abutment cases, there are no screw rest seats for these, okay? And then the third and final restoration that I wanted to show you guys, an example of how we can pull this in, would be the post and core restoration type. So this is the other new restoration type that we've added to MillBox. And this one works pretty well also. And there's a couple different ways that you can kind of cam these files out. So one of the features that I wanted to show you guys today, in addition to showing you these new restoration types, was the feature in particular of being able to use the paint tool or the designated milling zones to kind of come in and refine or designate areas for the cam to come in and do extra finishing. So in this case, I'm just going to pull in a 22mm disc, just something that fits all these restorations. Perfect, and that's been brought in. And so here's my post and core. I'm going to move it a little bit further in here so we can just have a better look at it. And I'm going to get rid of my disc. So, all right. And here's my post and core restoration. So at this point, really the only thing that I'm looking for are undercuts on the preparatory side. And some of these could actually be just bad scan data. But if you do need those areas to be milled out and they're not being captured from the initial insertion direction, this is a good use case scenario for the milling zone designation or that paintbrush tool. So this is where we can designate additional finishing operations to be executed on this part. And this is really handy when you have particular cases that may have some undercuts, and maybe you have some undercuts that you want milled out, but others that you don't necessarily want milled out. That's one way of specifying it, but you can affect a couple different operations here. So there is additional interproximal detail. This is like using a 0.6mm tool, and you could use this on like a bridge. Where this really works well is particularly on bridges where you have in the interproximal area, you have really tight shapes and clearances, and using that 0.6mm tool is really nice to go in, and in particular you can paint where you want it to go. Otherwise, if you just want to do like undercuts, you can say I want to hit the undercuts with, and this is my 1mm tool. This is also my 1mm, and then the anatomic detail is going to be typically like a 0.3 in the case of a Roland, but it can vary based on your machine as well. So you can check with your dealer for specifics there. Now, what I'm going to do is I'm going to come in and specify some undercut areas, because I can see that there's some areas here where undercuts are present, indicated by that blue shaded area. And I'm just going to come in and kind of color that, that area and allow the cam to kind of designate that spot as needing additional attention for that tool. And what you can see actually happens is it opens up a part border or offset around here. Now, why did it do that? Very important, the reason it did that. Our tool needs the clearance to actually come in from this angle and fit into this channel. So if it was trying to accomplish that without this offset being open, you can see the clearance issue that you could potentially have here. So let me just redo those two steps there, and that's going to bring it back. Now, what if I want to paint more zones? Like, what if I want to paint this zone over here as well? Well, right now, I'm still painting for the first operation that I've designated. If I come over here and start painting more, it's actually going to, now these stay grouped, but one thing you'll notice is as I come in here, if I just simply change the angle and click, you'll see that this arrow adjusts according to the angle I'm looking at it, including what material was kind of cut away. Now, because I wanted it to kind of come in from this particular angle, I want to get my angle just right, and that's when you go in and paint and designate your surface, because it's going to take your orientation or your view orientation into account as you're designating that. What if I want to get rid of this zone? Well, I can just simply go in and delete that zone out like that, and it'll simply remove it. If I want to add another operation, like let's say that these undercuts over here are imperative, I need these to be milled out. I can go to my select operation, and where it says undercut 3+2, I can simply come in here and again just paint the surface that I need, and we'll see a separate direction kind of come out. Well, what if I need a third direction? Like let's say that this nub right here, I want this to be milled out. simply go up to select operation type. Now this is because I'm currently painting one. So you would just go to here and click this and click on undercut 3+2. And then you can see the color changed, and that's to indicate that we have a new machining grouping that we're going to utilize. And then you can see here that it projects the offset again according to that odd angle that I want to come in from. So realistically, I could probably come in and hit some of these areas as well, but honestly, these were more optional. I didn't really need to do this. I just was doing that to show you guys as a good example. Now, what about on regular cases like crown and bridge and abutments? Can you use that same tool? Of course we can. So again, just going to milling zone designation, select the type of operation, and if you want to hit some of these undercuts, like in the interproximal here that were designed, I can hit those undercuts just by painting that surface. And again, it opens up that offset. And this probably even gives me additional clearance to come in down here and finish from the bottom. So I can, let's say I wanted to hit that area. Now, it's always optional for me to paint this. Do I need to paint these surfaces? Not necessarily, because we do have automated operations that will go in and work on these spots. Now, where this operation comes into handy is the automated operations. In order for those to get in and fit in there, it doesn't expand the offset where it's needed automatically like this tool does. So that's the reason I like this tool, is if you have those cases that are a little bit more steep of an angulation that you're going to need to maybe remove some of the offset in order to create that additional machining clearance to even come in and hit that spot. This is where this tool really comes in handy and really can kind of shine. So I'm just kind of going in here and painting surfaces from different angles, so that way I'll have that additional material refinement after the machining is done. And so just in the interest of time, I won't calculate this or simulate it, but any of you guys that have MillBox are more than welcome to try it, or you can YouTube some videos on our paintbrush tool where you can kind of see this in action. So yeah, and so I can use this for any type of restoration. It's not relegated to single units. I can use it for this bridge as well. Now on this bridge, there's so many undercuts, and it's mostly on the facial here. There's so many undercuts, I wouldn't probably want to go in and have to manually designate these. I would just leave that open to the automatic operations, and then I would just increase my part border or offset like to 4 millimeters. So that way we have plenty of space and clearance to kind of get those tools in there. And as you can see, we can see those undercuts a lot more readily now. So there's just a couple, there's always a couple different ways, let's say, to skin a cat. There's always different methods you can go about things. So this is just one of those additional flexible tools that we've implemented that really kind of help drive home the capability of the cam to really mill anything that you want to throw at it. So that's where we've kind of increased our flexibility and focus, particularly on the MillBox development side over the past couple of years. So we've covered 2 of our talking points. The last talking point that I want to talk with you guys about is going to be the abutment screw hole obstructions and errors that we detect with files. This is particularly an important issue for anybody that's doing CAD/CAM, regardless of your CAM software, regardless of how good you think your milling strategies are, your templates are, or even the detection of your CAM software. At the end of the day, there are just certain features and certain problems with STL files that are irreconcilable to be able to CAM a file. And what does that mean? That means that there could be a hole in the STL's mesh. That could mean that there could be an obstruction to the screw channel. So, our CAM software's job is not only to figure out how to rough this part out or how to cut this part out, but also how do we do that without having any collisions. And that includes the geometry of the part, as well as the disc, as well as the fixture of the machine, the spindle, the tool. Everything is accommodated or everything is accounted for physically as we're doing these calculations. Now, what does that mean? Well, we can't violate any of those rules, and that includes cutting through the surface of the STL. So if there's a problem with the STL file, then we're going to want to fix that. So I would say 9 times out of 10, the automatic fixing works really, really well. But in some cases, I may need to make adjustments to the screw channel. So I would say by default, you could say yes. And if something didn't correct itself properly, you can always hit the undo button to undo those mistakes. But I'm going to say no for this particular example because I just want to illustrate the problems here that we're encountering. So these are some of the new changes that MillBox has that we've implemented in MillBox over the past year. And you may notice some of the older versions, after the calculation or during the calculation, you might get a message or something like that saying that the CAM software or some surfaces may not be fully machined due to the collision protection surfaces or to avoid collisions. And basically what that means is some operations get truncated or they get shortened because in order for it to achieve the cutting of a particular surface, it would have to violate that rule of having a collision, whether that's colliding with the part or colliding with the disc or whatever else you may be thinking about. So in our particular example here, the software has found an issue, and not only has it found the issue, but it's actually showing us where that issue is. Now, in some cases, these issues we may not be able to see with our naked eye. What does that mean? Well, that means that there could be an obstruction to the borehole. There could be that the mesh or the data in the mesh is inconsistent, and so it throws the cam for a loop. But the easiest way to kind of tell what's going on with the case is first you want to look at the borehole. Now, this is a very unique type case because you can see here the screw channel itself is not actually cylindrical in shape, and you can see based off the profile that we generate here that it's actually almost like 2 cylinders that have been kind of combined, and that's very typical for a angled screw channel. You're going to see this a lot on your angled cases. Now, in order for me to fix this, first of all, I want to make sure that my drilling axis is correct, because if the axis is not correct, it's not potentially looking at the right information. So that's the first thing. First and foremost, I want to fix that. In the new version of MillBox, as you can see here, I can just kind of hover my mouse over top of drilling axis and select that. That's also a new feature in the newer version. But you can see we get a cylinder projected along that drilling axis. So at this point, what I want to make sure is happening is I want to make sure the drilling axis is the correct height, which it looks like it is. I could increase the height and shift it up just a little bit, just to be extra safe there. And once we've done that and the drilling axis is 100% correct, then we can go in and select this, and it's going to say, okay, we found an error here. Do we want to change the mesh? Which means MillBox is actually going to come in and modify the mesh in that particular area where it saw the problem. So you can see it in some areas, it looks like it remeshed, restitched some zones down here. But effectively that fixes the issue for the CAM, and the CAM is now able to process this file. So what's the importance of having that curve in the correct place? Well, this is so this bridge will be a great example of that. And then once we're done showing that, we'll kind of move on to some of your all's questions. So this bridge, this is actually a live case. So this was not a demo case or anything. This was sent to me by a customer just yesterday in terms of technical support. And the issue that they were running into is they just couldn't cam it on that older version. Now, ideally, the only way that we would have to tell the customer of fixing this problem is you have to go back to the CAD. You have to make sure you're not overbuilding material over the screw channels. Re-output the file, see if that helps. A lot of time-consuming pieces that aren't always the most straightforward. So again, we can see here that if I select this screw channel, here you can see it's not the correct one. It's actually pulling the axis down from below here. I need another axis up top here before I can correct this issue. Well, what if I just try to correct this issue? Well, let's see what happens. Let's see. Let me get this a little bit further away from the fixture so that way it stops turning red on us. There we go. All right, so let's see what happens when I try to fix it. I haven't rehearsed this yet, so let's see. But what I would assume would happen is it might adjust the mesh incorrectly, and that's why you want to make sure you have the drilling axis to just protect the mesh that you actually need milled out. So we'll give this just a second here and see what it does. Okay, and you can see what it did there. Because the drilling axis, well, actually, right here, let me zoom out just a little bit. Yep. The drilling axis in this particular case wasn't high enough. So when it went in to fix the mesh or fix the problem there, it only fixed the mesh up to this point. So technically the tool could still encounter material here. And that's where I'm gonna wanna go back and take a couple steps back and actually fix that. So my first step here would be to come in and go to curves and surfaces, and then go to drilling, cylinder drilling axis. Now this is a new feature as well, being able to designate by 3 points. So I'm going to come in and designate a drilling axis based off of the top portion of this axis channel, because we can see that the angle, if we look at it, we can see that the angle changes just as we get down into there. So I can select 3 points, one here, and then we'll select one here. Okay, let's see if that detected well. All right, didn't do so well. So let me go a little bit higher on the cylinder. All right, there we go. That's a little bit more, it's a little bit better looking. So again, I'm just going to select this right here, making sure that my my drilling axis is tall enough. So I'm actually going to increase my height and then shift it up a little bit, because I want to make sure that it's completely clearing the STL. So that way there's no drilling obstructions that I have to worry about there. So now that that's done, I'm going to go in and again attempt to correct the issue. And it's important to understand what we're doing here, and this is why I said this was kind of unprecedented, because you're not going to see this in any other CAM software where it's actually coming in and modifying the mesh. Okay, so in my case, I may have gone a little bit too high. Let me go a little bit lower then, see if that helps. Okay, so I'll move on to the next one, but just to kind of show you here, the main problems that you used to run into, where it was completely irreconcilable, these issues can now, for the most part, be fixed. Now this was working earlier. I tested this particular one, and I may have to adjust the drilling axis and come back in and try to refix that mesh again. But generally speaking, you can come in here and make those modifications, and the CAM software will kind of accept those and move forward and fix them. So particularly over here, for example, we can go in and fix that, and it will fix that mesh. So sorry, my examples weren't 100% foolproof, but you can see that this is one, it's a new tool, and two, it's something that again you just don't see in the CAM software. So as time goes on, these tools are only going to improve. But the nice thing is you have an option outside of, oh, you have to redesign it, or oh, you have to re-output your STL file, or you have to use GeoMagic to come in here and edit it with a third-party CAD software. So it's those types of problems that we're trying to avoid, and ultimately that's some of the value that these new updates bring. So I hope that this presentation was fruitful for you guys, that you guys were able to see some of these new features in action.